We're going to start talking about outliers and influential points. Now, we talked a little bit about outliers in the first part of the unit. We talked about how they affect correlation. Correlation was non-resistant, okay? But as we're looking at the different aspects of these quantitative analyses, we're looking at regression lines, we're looking at slope and y-intercept, we're looking at correlation and correlation squared, we're looking at residual standard deviation. And so we want to know what these different outliers, what kind of effect they have on those concepts. So whenever we see unusual points in a scatter plot, and you don't have to write this down, okay? So when we have unusual points in a scatter plot, they may or may not have an influence on any of those regression analysis pieces. So we have correlation and correlation squared, we have our regression line, and we have our residual standard deviation. So sometimes we'll have outliers, we'll have these unusual points that will affect these. Other times, depending on where that outlier is located, it won't have an effect on some of these, okay? So as we're looking at this, we're going to investigate, we're going to show you kind of 4 different examples and kind of how these different outliers, how these different unusual points affect those different measures, okay? So in each of these scenarios, these first original points, so there's 8 points here. These are going to remain constant through all 4 scenarios. Now, the reason they have the graph set up this way, okay, instead of like zeroing in on the actual information, is because we're going to throw some outliers in here. So we're just using the same graph each time so we can see exactly how this all changes, okay? So as we're looking at this regression analysis, given these 8 points, if we create a regression line and we run our regression analysis, we get the regression line with the y-intercept of 3.04, slope of 0.65. We get a correlation value of 0.41, which tells us what? What does that correlation tell us about the association? Mm-hmm. 0.41 would be moderately weak, right? So moderately weak, linear association, okay, with the scatter plot in play there. We've got a correlation squared of 0.17. So 17% of the variation in y is accounted for by the model. And then we get a residual standard deviation of 2.77. And what does that residual standard deviation measure? Like just in general, what is my residual standard deviation measure? The what? Kind of.
How much the points spread around the regression?
Kind of. What's our phrase that we associate with? Typically, that's R squared.
Oh, typically off by.
Typically off by. So our typical prediction error, right? When we're doing the residual standard deviation, remember residuals are the prediction errors. How far off was the line from the actual point, right? So we're looking at the typical prediction error. So if I were to predict using my model, we will typically be off by about 2.77 whatever units, right? So that's what we're looking at there. Now I'm going to write these analysis measures down here so we can see how these change from one scenario to the next. Okay, so this is our initial regression analysis. This is with just our regular 8 points. There's no unusual values. Okay, so this is what we would have, and we could like interpret, analyze, do whatever we need to with this information, right? But let's say there's a 9th point in our data set, and that 9th point has an extreme value in the x direction, but it falls in line with the rest of the data. So a lot of these unusual points that are going to affect our different measures are going to have extreme values in the x direction. So it could be way larger than the rest. It could be way smaller than the rest depending on the situation. So we're looking at this extreme value in the x direction, either way too big or way too small compared to the rest. Now, if that extreme value lines up with the rest of the data, when we look at this new regression analysis and we look at what we had before with just the 8 original values, did that point have much of an effect on my regression line? No, it really didn't change the y-intercept, really didn't change the slope, right? So it didn't cause any change there, okay? But what do we notice? Yeah, R is way higher, right? At first we had a moderately weak association. If we were to classify this association, what would that correlation tell us? Really strong, right? Jumped all the way up to 0.94. Now, why might that be? It's right on the line, so it's right in line with everything else. It's going to add to that strength, but why does it add the strength? Like, think about how correlation was calculated. Why would it make sense that this would jump or make that correlation, make that association a lot stronger or appear much stronger? What do we use to calculate correlation besides our calculators? Z-scores. So we calculate Z-scores. Now, if I have this value that's extreme in the X direction, it lines up with the rest of the distribution, so it also has an extreme value in the Y direction. The Z-scores associated with this point are going to be huge. And so when I put that product in with the rest of my values here, it's going to increase that correlation by quite a bit. So because of that increased value for that Z-score on X, it's going to strengthen that correlation. Okay, and in this case, falsely increase because the overall association itself wasn't that strong. But this one point makes it seem very strong because the correlation jumped all the way up to 0.94, which in turn increases our correlation squared by quite a bit as well, and falsely tells us that this would be an accurate line. When our R squared was first, it was a 17%. That means that it's probably not going to predict very accurately. Only 17% of the variation was accounted for. I add this point in, and now all of a sudden our correlation squared is 0.89. Makes it seem way more accurate than it is. Okay? When I look at the residual standard deviation, didn't change much, but it did change slightly, so it did have a little bit of an influence there. Okay? But what this type of point will typically do when it's extreme in the X, again, could be way larger, way smaller, but if it lines up with the rest, it's going to greatly alter that correlation value. And therefore, that correlation square is going to make it appear much stronger than it is. So it's always going to strengthen that association. It won't have much of an effect on the regression line because it's in line with everything else already. And then it'll have a slight effect on the residual standard deviation, just kind of depending how the data spreads around the line there. So that's one type we want to be on the lookout for. That would be an unusual value that falsely strengthens the association. When we look at this next example, we move that point, so now it's still an extreme value in the X direction, but now it does not line up with the rest of the data. So when we had the original 8 points, we had that positive linear association was moderately weak. As soon as I add this point in the extreme X direction, in this case again, extremely large compared to the rest, when we look at our regression line, what's happened? It's completely different. Okay, not only is the line different, but as far as the association is concerned, what's happened? It turned to a negative association. So I had a positive, linear, moderately weak association. This one point created a negative association. Okay, so when we looked at that now, we have the completely different regression line. My y-intercept is completely different. My slope changed signs. My correlation, now as far as correlation value, the value itself isn't that different, 0.41 versus 0.34, but now it's in the opposite direction. It was a positive correlation, now it's a negative correlation. So now it's a negative, moderately weak. Correlation squared always positive to begin with, also changes a little bit. So from 17% drops down to 12%. And then my residual standard deviation, again, changes a little bit here where it becomes a little bit less accurate. So we're going to have a typical prediction error that's a little bit larger. So when I have these values that are extreme in the x direction, again, could be too large, too small. If they don't line up with the data, they're pretty much going to change everything. And in some cases, they can even change the entire direction of the association depending on their location. The other type of unusual point that we can encounter is one that has an extreme value in the y direction. So the x value more or less lines up with the rest of the data, but this time it has an extreme y value, either way larger or way smaller than the other points. So basically it doesn't follow the overall pattern. Now when we throw a value like this in, okay, we look at our regression analysis and we look at how it changes. So as we're looking at our regression line, as far as the regression line goes, did it affect it?
The y-intercept.
Yeah, it affected the y-intercept. Did it really affect the slope at all? No. And so one of the things, as we're looking at these and we're kind of thinking about how these points are going to affect what we're looking at, if you think about, think about this, the line that we create kind of as like a seesaw or teeter-totter, right? Every point is going to be pulling that line to itself. So every line's trying to pull on that line somehow, okay? It's trying to pull it to itself. And so when we're looking at this, where our original line did pass through the middle of our data, the minute I throw a point up here, that point is going to try to pull the entire line up to it. Now, since it's pulling at the middle, right, and again, it's kind of hard to see that because the graph is set up in a weird way, but since it's pulling in the middle, it's going to pull the seesaw up, but it's not going to affect the slope of it hardly at all. It's just pulling the whole thing up towards itself. So it does affect that y-intercept. It increases it by quite a bit, but it's not going to affect the overall slope. What do we notice that it does to the correlation? It makes it weaker, right? Which is expected. The correlation is supposed to measure the strength, how we vary around the line. That value is way off the beaten path. It's going to weaken the association overall. So we dropped all the way from 0.41 to 0.11. Now we're not moderately weak, we're weak, right? So now we have a much weaker association, much lower correlation squared value, so much less variation accounted for by the model. And we notice that it dramatically increased our residual standard deviation, which would make sense because what's this point? How would that make that a lot larger here? Yeah, it's way further off than the rest of the points, right? That's going to have a huge residual compared to the rest, okay? So it's going to have a large residual, which is going to greatly increase that residual standard deviation. So as we examined these different scenarios here, what we noticed was that we have a couple different things that can happen. So when we classify unusual points, there are points that can be classified as high leverage. So again, if we think about the entire distribution, if we think about our regression line as kind of like a seesaw, right? We know physics with levers and fulcrums and things like that. The further away I apply a force, the less force it requires to move the object, right? So those extreme values in the x direction, those have high leverage because they don't require much force to pull the line wherever they want it to go. So we saw that one point changed a positive association into a negative association. So when we have much larger, much smaller x values, we're going to have high leverage because it requires less force to pull. So they're going to have a much more dramatic effect on the slope, a lot of times on the y-intercept as well, because as soon as the slope changes, the y-intercept has to change. Remember, we're balancing on that fulcrum on the center of the x variable. So those are going to have high leverage. Outliers are going to be those ones that have the extreme y value. They don't follow the general pattern. They have large residuals. And then influential points are any points which, if we remove them, or like in our case, we added them in, they substantially change the value of the different regression measures. Now, in most cases, if we classify a value as high leverage or outlier or outliers, they're also going to be influential points. Now, when we classify things as influential points, we do need to be specific as to what they influence, because we did see some times where we had an outlier that affected one thing but not another. Extreme in the x, but in line, didn't change our regression line. Had no effect on slope, no effect on y-intercept, or hardly any at all. But it greatly increased our correlation value and our correlation squared. Didn't change our residual standard deviation much, so it was influential primarily on that correlation and correlation squared value. So when you're talking about these different types of points, if it's extreme in the x, it's a high leverage, which means it's also influential on something. So then you would specify what it's influential on. It's going to greatly increase or decrease this, or greatly change this value, whatever the case may be. And then the outliers, when they have those large residuals, those are the ones with the extreme y values. Then we talk about, as far as influential points, what are they going to influence? They're going to influence that residual standard deviation. They're going to weaken the overall pattern, so weaken the correlation. So we talk about the way it influences those different values. Okay, so we talked about a little bit, like the outliers. We talked a little bit about that in the first part of the unit. Now we're just being a little more formal with it, talking about exactly kind of how it affects things, what it looks like. Okay, so then another example here, so you guys can get a feel for what this looks like. So it's kind of blurry on here. So do the best you can as you're looking at this. But if we're looking at this association, so age at first word in months versus a Gesell score. Says, how would you classify children 18 and 19 in the scatter plot below? If they're influential, what would they influence? So if we're looking at child 19, which is this value, this dot right here, and child 18 over here, and then it also gives us a residual plot, okay, so we can also analyze that. So if I were looking at child number 19, and I wanted you to classify that unusual point, what would we classify it as? So high leverage or outlier? Outlier. And the reason we call it an outlier is because it's extreme in the y direction. It has a large residual compared to the rest, right? So we can actually see how much further away from the line it is, okay? So it is an outlier, which means it will be influential, but not on everything. What is that child probably going to have an influence on? So think about our values here. What? R squared, and R would have an effect on it. What effect would it have on it? Decrease, well, weaken, yeah. So one thing I want you guys to be careful with when you talk about correlation, right, we have positive, negative. And so when we say increase, decrease, right, sometimes that gets a little bit iffy when we're talking about the negative and we say we increase our correlation, but it was negative to begin with. Increasing a negative number as actually making a smaller number, right? So instead of saying increase, decrease, let's talk about strength and weakening. Okay, so it's going to weaken the association, right? So it definitely weaken the association. We get a lower correlation and correlation squared value. What else might it affect? The y-intercept is going to pull the line towards itself, right? Is it going to have much effect on the slope?
No.
Probably not, because it's right in the middle, right? So it's going to pull it up, but it's probably not going to tip it one way or another, okay? What else is it probably going to influence then? So correlation and correlation squared,
Oh, the standard deviation.
the residual standard deviation, right? It's going to have a larger residual standard deviation because of that point. So it's going to have a large residual. I put a large value into my calculation. It's going to increase that overall residual standard deviation. So it's going to be influential on all those values there. The only thing it's not going to affect really is going to be the slope. Now, as far as child 18, how would we classify that? So influential, but what type of influential point? High leverage or outlier? High leverage. Now, is this a high leverage that's off the beaten path or high leverage in line? Kind of in line, right? If we think of the overall, right, more like the majority of the data looks like a slightly like negative association, right? Okay, so this is going to be in line with the rest, so high leverage. So if I think about high leverage in line, is it going to affect the regression line much? Not necessarily, okay? So the only thing would maybe be because child 19's in there right now too, so the line's kind of pulled up, this might pull it a little bit towards itself, like this is going to have more leverage than the child 19, so it might outweigh that a little bit, okay? But it's probably not going to affect that as much as it's going to affect what? Correlation. How's it going to affect correlation? It's going to strengthen it, so it's going to make it look much stronger than we have. Okay. Is it going to affect standard deviation? Probably not a whole lot, right? Maybe a little bit, but probably not a whole lot that's in line with the rest, so it should be, it's already pretty close to the line, right? So it's not going to do too much in terms of affecting that as much. So it's mostly going to be that correlation squared value, okay? And so we can look at that just as some of the values. It doesn't have standard deviation on here. But if I put all 19 children in, I have a correlation value of negative 0.64. I've got a slope and y-intercept for my regression line. When we remove child 19, right, we got a stronger association like we expected. When we remove it, so this was making it weaker. We remove it, we get stronger. Did not change, in this case, much of anything as far as the y-intercept. Now, the reason it didn't change much is what? It's in the middle, so should have pulled it up a little bit, and it did. And so, like, when we're looking at this, when we remove that child 19, the problem we have is we still have this high leverage point in there, right? And this is going to affect things much more than that outlier is going to. So that's going to kind of keep things from going too crazy. Now, if we remove both, then we're going to see lots of changes, okay? So that's what we're looking at there. If we take out child 18, we weaken the association like we expected. So it was falsely overemphasizing the strength of the association. We take it out, we get a much weaker association. It also greatly affected the slope and the y-intercept as well. So it's pulling down on that line quite a bit. When we release that, line levels back out. Okay? So those are the kinds of things we're thinking about there. So as far as the homework today, hopefully you don't get too overwhelmed with the length of it. You're going to have some questions just about these outliers. How do we classify them? What are they going to affect? What are the values going to look like as we do that? So you guys can try these out.